There are a lot of videos which show you how to make a mini AC or a mini cooler kind of a thing, and it is going viral, and I also wanted to try it out. I have my own reasons for trying this out, so I will share all of those in the course of this video. There are a lot of fake videos out there, so there is no telling whether it would work or not work, and therefore I have made one myself. And don't skip the video after listening to what I have to say. It did not quite work well for me. I mean, not the way they show in the other videos. So rather than making a video about my failed attempt, I'm going to try and explain the concept of how this is supposed to function. I mean, at least the way I understood it. I will show you the making of it, how I made it, and all of my mistakes. I've also made some observations of my own, so if you're going to make this as a school project or a weekend project, I'm sure this video will be of some help. First and foremost, let me make clear that this is not a free energy video. This system requires electricity. Here in the heart of the setup, there is a pump which requires about 12 volts and 2 amps of electricity which is supplied to this charger. Let me try and explain the setup so that you can understand what is happening here, the components and all of that. You can see here that this setup has got a lot of copper tubes which are rolled as coils. Now this one is called the condenser coil, this one is called the capillary coil, and this one is called the evaporator coil. The condenser coil is about 4 mm in inner diameter, the capillary coil is about 1 mm in diameter, the inner diameter, and the evaporator coil has got about 6 mm inner diameter. The fans are here to dissipate the heat and cold on the either side, and the pump is going to push the gas that we are going to fill into the system. And by the way, the fans and the pump, they are connected to this charger, which is about rated about 12 volt and 2 amps. So how is it supposed to work? Let me give you an example. When we use a manual air pump, when we compress the air, we realize that the body of the air pump, it's getting warmer a little bit. And that happens because when air is compressed, the molecules come closer to each other, they collide with each other, and this causes heat. And this heat is dissipated into the environment as heat energy. But when the air is getting back to its normal state, the opposite happens. They take the energy from the surroundings, thus making it colder. I hope you are with me till this point. It will be safe to say certain things are suitable for certain purposes. Likewise, certain gases are optimized for refrigeration purposes. The basic criteria for any gas to be utilized in refrigeration purposes would be, in case if there is a leak, it should not be toxic, it should not be flammable, and it should be able to give the maximum cooling effect. But are these criteria met? Now that's a totally different topic to discuss. So let me circle back to the gas expansion concept, which kind of creates the cooling effect. If you have ever used a butane canister like this, upon prolonged use, you can notice that the canister's body, it gets colder. Sometimes you can see the frost forming on the body of the canister. Someone must have noticed this, and they chose to put this gas into a mini AC like this. Note that this gas is flammable, and if something goes wrong, this project can blow up on my face. Just imagine this gas being filled in an AC or a refrigerator. It could simply blow up the house, something goes wrong. Not only your house, your neighbors too. So you've been warned. This is a fair warning, so be careful when you do this. Alright, with all that cleared up, let's make it. The copper pipe with 6 mm diameter will be made into a coil, and this would form the evaporator of the cooler. To wind it into a coil shape, I am using an old paint can as a support to keep the winding smooth and uniform. So this is how it looks. The 4 mm coil will form the condenser. The length of these pipes are approximately 1 meter. The condenser coil has to be smaller in diameter than the evaporator coil. So I'm obviously using a smaller tin can as a support to achieve this. With this, the condenser coil is complete. We repeat this process for the capillary tube, but it will be coiled with even lesser overall diameter. So here I used a sketch pen and used it as a support to make the coil. The idea here is the gas will enter into the condenser coil, get compressed a little bit, and will be pushed through the capillary tube. The expanded gas gets compressed again, generating heat, but as soon as it enters the evaporator, it would have enough space to expand and thus creating a cooling effect. But soon the pump would suck it back in and push it into the condenser coil, and the cycle repeats. I have bent the ends of the capillary tube for a better solder. The coils were secured using a thin strip of aluminum and screwed to the wooden base. I used some soldering paste and used butane torch to solder, but it was way too powerful and blew the lead away. It was let to cool and I came back with the soldering iron and completed this step. The pump was secured to the wooden base using an aluminum strip as well. You can see here that I have attached a CPU fan in front of the evaporator coil to draw out the cold air. A smaller fan is added near the condenser coil to dissipate the heat. Using this small motor was a big mistake. When I plugged it in, it shorted out as the amperage and the voltage was too high for this motor. Later, I replaced it with another fan with proper voltage rating. The wiring is simple. All the positive terminals are connected to the positive of the charger and the negatives to the negative. You can see here that both the fans and the pump are working correctly. The next step would be to connect the pump. For this, a tube is connected to the free end of the evaporator and the suction end of the pump. Similarly, another pipe is connected from the exit end of the pump to the free end of the condenser coil. The setup is complete. Now let us fill it with gas. This part of the project you will have to be very careful. Please don't fill the gas in a place where there is any potential sparks or a fire accident. Don't try and hold the nozzle with your finger because it gets really cold. It almost hurt the fingers, almost like a frostbite kind of a feel. Every time I filled the gas, it would escape even before I had a chance to seal it. Also, the exiting gas is cold enough to make the floppy plastic tube rigid. After a few frustrating failed attempts, I came up with a trick to fix this issue. I pasted a small piece of rubber on the plastic tube using super glue. I kept a similar piece laced with glue ready. Then the syringe needle was inserted into the plastic tube, piercing the rubber piece. As I filled the gas, the cold gas made the rubber piece rigid, but promptly removing the syringe and sealing the hole with the spare rubber piece worked. Rest of the joints were tied up with rubber tubes as well. When I switched it on, there was a slight difference in temperature on the coil, but nothing was significant. It kind of worked. I could feel a little bit of a temperature difference, but it was not that significant. Has the gas leaked out? To check this, I cut one end of the tube and I got a lighter closer to the tube. Nothing really happened. Then I switched on the pump and then brought the lighter closer to the tube, and this is what happened. And it went up in flames. It's an indication that the gas was still sealed, but we somehow did not get the cooling effect. Let us say that we got this to work properly. So what can we do with this? This can actually be a really cool science project and we can explain the concepts of refrigeration or AC or something like that. That is in case if you get this to work properly. Can we use this as a mini cooler? No. It's like asking, will the room get colder if I leave the refrigerator open? See, a refrigerator is an insulated system and it kind of transfers all of the heat from inside the refrigerator to the outside the refrigerator. So if you leave the refrigerator open, the heat and the cold, they are going to cancel each other out and the room is going to be the same temperature just as it was before. But for an air conditioner, the entire room is supposed to be an insulated sort of a setup where the heat from inside the room is taken and transferred outside the room. In a split AC, the compressor is outside the room, and in a window AC, the part where the hot air is thrown to the environment is outside the window. Here in this project, the hot side and the cold side are exposed to each other just like leaving the refrigerator open inside a room, so they are going to cancel each other out. In order to make this efficient, we will have to somehow insulate the cold side, and that is if it works, and that opens up several possibilities. And hey, let's brainstorm together, share your ideas. I'm not going to try this project again, but your comments, your ideas could spark someone's next big project. Thanks for watching and remember to stay curious. Until next time, I'm Josh and I'll see you soon.